Have you ever just stopped and wondered what actually happens inside your computer between the exact moment you type a command on your keyboard and the split second later when the screen instantly changes right in front of your eyes? Honestly, it feels like magic sometimes, right? But the truth is, there's an entire invisible chain of events, this incredibly organized system that's working behind the scenes to make those billions of calculations happen flawlessly.
Welcome to this explainer. Today, we're going to completely demystify this process by exploring the architecture of the Linux operating system. And to explain this in detail, using simple, everyday words, we're actually going to view Linux as a highly organized corporate business. We'll call it the Linux company. Because just like any major corporation, your computer absolutely needs a boss. It needs workers, and it needs a very strict chain of command to avoid total chaos. I'm so excited to guide you through this, because once you see the operating system through this specific lens, I promise you'll never look at your computer the exact same way again.
All right, let's take a quick look at our orientation schedule for today. First, we'll map out the big picture. Then, we'll meet the key players running the show. After that, we'll see exactly how they open the office every single morning, dive into how they keep track of everything using logs, and finally, we'll hand you the official employee handbook with the golden rules. Okay, starting off with Section 1, the Linux Company Big Picture. Welcome to Linux Inc. Let's look at the high-level flow of how requests actually move through our company. Check out this strict chain of command. From the second you, the customer, make a request to the moment the physical hardware executes the task, there is a very specific flow. It goes from user to the shell, down to the kernel, through the translators, and finally reaches the hardware. The absolute most important takeaway from this big picture: you, the user, never directly touch the hardware. Every single thing has to follow this strict corporate hierarchy. Now, this system is ridiculously easy to remember if we just assign everyone a job title. Think of the shell as the front desk secretary. You walk in and hand your request to the secretary. The secretary then passes it to the kernel, who is the main brain, the CEO of the company. But here's the thing, the CEO doesn't naturally speak the native language of your printers or your monitors. So the CEO uses modules, which act as translators, to give instructions to the hardware, which are the actual factory floor workers getting their hands dirty. Moving right along to Section 2, meet the key players. Let's get to know the specific employees who are keeping this operating system running so smoothly. So the crucial point here is the strict division of labor. The kernel is the absolute core of the OS. It's the king, the CEO. It controls all the vital, high-value resources: your CPU, the RAM, the disk, the network. Literally, without it, the whole system just collapses. But think about it. For security reasons, if any random user could just waltz into the CEO's office and mess with the RAM or disk directly, the system would crash constantly. That's exactly why you have the shell. The shell is your safe interface. It controls user access and makes sure your commands are passed along securely. Now, what about those translators we just mentioned? If you're coming over from Windows, you almost certainly know the word driver to describe the software that helps your OS talk to, say, a graphics card. But in Linux territory, we use the term module. A module is essentially a specialized piece of code that gets loaded directly into the kernel exactly when it's needed. Think of them like plugins or mobile apps that instantly add brand new capabilities to your phone on the fly. Just keep in mind that these module translators hang out in a very specific directory. Think of /lib/modules as a dedicated filing cabinet in the office. They literally just sit in that cabinet until the CEO actually needs to talk to a new worker. Like when you plug in a new USB drive. The second you plug that drive in, Linux dynamically pulls the right file from the cabinet and loads the USB module. And hey, if you ever need to load one yourself as the system admin, you can manually do it using a command called modprobe. Real quick, before we talk about booting up, I absolutely have to mention dbus. If the shell and the kernel are how users talk to the system, how do the actual programs talk to each other? Well, dbus is basically the company's internal messaging app. It's the Linux WhatsApp. It's this super efficient communication system that lets background services easily send messages back and forth. This is exactly how your background Bluetooth service tells your visible desktop interface to pop up a notification that your headphones are connected. All right, Section 3, opening the office. Now that we know the staff, let's see how they actually unlock the doors and open up the office every single morning during the boot process. This step-by-step flow shows you the exact sequence of waking up the company. You hit power on, the hardware's BIOS or UEFI runs its basic checks, then hands things off to Grub.
Grub is the bootloader. Basically, it's the alarm clock whose sole job is to wake up the kernel. The kernel wakes up and loads, but there's a little catch. The kernel might not immediately know how to read your complex, real root file system. So it relies on a temporary environment called the initrd to get things moving.
Think of the initrd, or initramfs, as a mechanic's emergency toolkit. The kernel has to bring this little toolkit along because it contains the absolute most critical drivers and modules. We're talking about the specific disk and file system translators needed just to unlock the main doors of the building. It's really just a temporary mini Linux environment used solely during boot up, right before the full company can open for business.
But what happens if you lose your toolkit? If that init rod is missing or gets corrupted somehow, the kernel wakes up, tries to access the hard disk to start the OS, and suddenly realizes it doesn't have the tools to read it. This results in a pretty terrifying scenario known as a kernel panic. Basically, the Linux brain crashes and the operating system completely stops in its tracks because a vital component failed. Thankfully, if things do break, or a file system gets corrupted, or even if you just completely forget your administrator password, there is a backup plan. You can boot the system into rescue mode. You can think of this as the ICU mode for Linux. It gives you a very minimal, stripped-down environment specifically designed for system repair, so you can diagnose the problem and get the company back up and running. Section 4. Keeping track with logs. Every good business needs to keep meticulous records, right? Let's explore how Linux handles its internal tracking.
Logs act as your security cameras. They're literally the CCTV footage of your operating system. Linux is constantly recording everything: boot events, errors, user activity, hardware changes, you name it. And this perfectly explains why they're stored in the /var/log directory. var stands for variable. Because log data is continuously changing and growing larger every single second, it needs a dedicated variable space to live in.
So how do we actually watch this CCTV footage? Well, if you want to see pure hardware detection or direct kernel messages, you use the command dmask. Now, older systems relied heavily on traditional text-based files like /var/log/messages for their general logs. But modern Linux systems, they use journal-ctl. And what's really amazing about journal-ctl is that it stores logs in a binary format. This makes it incredibly fast, highly structured, and super easy to search through when you're hunting down a specific system event. Finally, Section 5, the Golden Rules. We're going to distill everything we've learned today into a quick employee handbook of essential commands. Here are the fundamental command line interface, or CLI commands, that you should basically commit to memory forever. uname-r tells you exactly which CO version is currently running. Echo $shell introduces you to your current secretary. lsmod lets you list out all the currently loaded translator modules, while modprobe lets you manually load a new one. And of course, dmask and journal-ctl are your ultimate go-to tools to review the company's CCTV logs. Look, if you only take away one single thing from this entire explainer, let it be this golden line that perfectly summarizes the entire Linux architecture in plain English. User talks to shell, shell talks to kernel, kernel uses modules to control hardware. That is the genius division of labor that makes Linux so incredibly powerful, stable, and secure. And that officially brings us to the end of our corporate tour. So now that you know exactly who runs the Linux company, from the CEO sitting at the top all the way down to the hardware workers on the floor, what are you going to command them to build next? I highly encourage you to open up your own command line interface today, try out those memory commands, and just start exploring. Thanks so much for joining me on The Explainer, and keep learning.